and we have this to be less than or equal to. In case of exam situation, we have had sometimes there might like to be a phobia. So look at this. You can use this to remember your right hand side, to remember your greater than. This is your right hand side. And your left hand side to remember your less than. Now, and this less than can change to greater than. And greater than or equal to can also change to less than or equal to. And what are the conditions that can warrant those changes? The first condition that can warrant those changes is turning events. Turning events. Turning events simply means if you have two greater than x, and this has two sides. It has right hand side and it has left hand side. And most of the cases, we want our unknown to be at left hand side. Therefore, we can turn it. By turning it, as if you are turning the steering of your car, it will be x less than 2. That's what you call turning event. And the second one is negative event. Negative event. Negative event simply means by dividing both sides by negative, irrespective of whatever you are given as right hand side and left hand side. In as much as you divide both sides by negative, then your inequality sign will be affected. For example, let's say we are given 2x less than or equal to 6. Now for this, we can say that divide both sides by -2, which is coefficients of x. Divide both sides by -2, we have -2x divided by -2 less than or equal to 6 divided by -2. Now, as we've divided both sides by -2, this -2 and this -2, there's now be x greater than or equal to -2 here, 1, 2 here, 3. Now, -3 and -1, the same thing as -3 and 1. This one, they are all 3. This one is -3, and this one as well is -3. Therefore, the answer here is -3. So it's now be x greater than or equal to -3. Because of this, the fact that we divided both sides by minus, the inequality sign has been affected. What if we now have -x greater than 0? Now you are looking for the value of x. Now, in as much that we are still going to divide both sides by minus, because coefficients of x here is -1. So we also say that divide both sides by -1. So it should be -x divided by -1 greater than 0 divided by -1. Now here, any number, if you want to any number, if you use any number to divide 0, then your answer will be 0. But if you use 0 to divide any number, your answer will be infinity. So this one will give us x greater than 0. Let's now proceed to our today's question. The question is, illustrate graphically and shade the region in which the inequality y minus 2x less than 5, comma, y greater than or equal to minus 2x, comma, x less than 1. These are simultaneous inequality that to be represented on graph. So that means I want to solve this one graphically. And that is why the question reads us, illustrate the graphical and say the region in which the inequality, these given inequalities are simultaneously true. Now, I want to represent this on graph. I want to indicate and shade the region where satisfy this inequality questions. Now, the first thing to be done is, in order to have our graph to be done, we need coordinates. So we need coordinate for this, and coordinate for the last one. So the first one, you assume that this one is a normal equation. You assume that it's a normal equation, which is y minus 2x is equal to 5. Because we want to have a straight line graph for this. So the first thing, having assumed that this one is a normal graph, then normal equation, which is equal to, then we now find the coordinates in order to have our straight line. So the first thing is you assume that your x, if x is equal to 0, you assume that your x is equal to 0. Now, if your x is equal to 0, then what will now be the corresponding value of y at x is equal to 0? All what you need to do is to substitute 0 for the value of your x here. So we now have y minus 2 into bracket 0 is equal to 5. That is y, 2 times 0 is 0, minus 0 is equal to 5. Therefore, y is equal to 5. Now, when our x is equal to 0, y is equal to 5. Then we can now write this one in terms of a coordinate point, which is 0, 5. Because in coordinates, if we have x, y, so we write x before y. So this is the first one. Then, because we are talking about a straight line, we need two coordinates. This one is one's coordinate. Now, for the other coordinate, we now assume now that what of our y is equal to 0. Because the first one, we assume that if our x is equal to 0. Now, let's now assume if y is equal to 0. So we are still going back to our equation by substituting for the value of y to be 0. So we have 0 minus 2x is equal to 5. That means that we have minus 2x is equal to 5. Now divide both sides by minus 2. So we have minus 2x divided by minus 2 is equal to 5 divided by minus 2. Now minus 2, remove minus 2. So we have x is equal to minus, how many 2? We see in 5, that is 2. Remainder 1, that is 1 over 2, with the same thing at 2.5. Now for the second coordinate, so we can have minus 2.5, 0. So this is coordinate. These are the coordinates for the first one. Now, let's proceed to the second one, which is this. We have y greater than or equal to minus 2x. Now, we can now assume, like the previous one, that if our x is equal to 0. So, if our x is equal to 0, we have y, well, we firstly assume that y is equal to minus 2x. Come to the normal equation because we are talking about the straight line. So you need the normal equation to get your straight line. So we have then, if x is equal to 0, so it will now be y is equal to minus 2 into bracket 0. So that means that y is equal to 0. So for the first coordinate, we have at the origin, which is 0, 0. That is y is equal to 0 and x is equal to 0. Now, the next thing now is you now be thinking what is going to be the next thing to be done. Because for the second one, if you say that if our y is equal to 0, we are still going to get 0 for the value of our y. So what are we going to do? So in as much that we have our y to be equal to 0 and x to be equal to 0. So the next thing now is that you cannot proceed that, okay, having used the value of our x to be equal to 0, then let's now test for our x to be equal to 1. Why? Because if you say that our y is equal to 0, we are still going to get, for example, let's say if y to be equal to 0, go back to this, it will be 0 is equal to minus 2x. So divide both sides by minus 2. Minus 2, minus 2. That is 0 is equal to x. That is our x is equal to 0. So it's going to be 0, 0. So when we are already having our 0, 0. So this one is not of use anymore because we can have the same point as at the time to have a straight line. It's not possible. So what you need to do is to assume that if x is equal to 1. The question is it only x? What if you are assumed instead of using x, in as much that I already assumed for the x before, what if you are now assume y? Yes, you are still going to get the same thing. It's not necessary that you restrict yourself to the fact that our x should be equal to 1. You can say that if x is equal to 2, if x is equal to 3, or if y is equal to 1, because you can't use 0. So if y is equal to 2, you are still going to get the same thing, because we are talking about the straight line. And we say that straight line, what is the definition of a straight line? Is the distance between 2 points. So on a straight line, we can have thousands of points. And this coordinate represents a point. So you can have thousands of points in respective of whatever number that you are using. Now this one now, if our x is equal to 1, let's go back to this place. It's now be y is equal to minus 2 into bracket 1. So y now is equal to minus 2 multiplied by 1. That is minus 2. Now we are having 1 for our x and minus 2 for our y. So we can now write in terms of a point, which is coordinate point. So to be 1 comma minus 2. Now we are having normal coordinate. The first one, for this one, we are having 2 coordinates, which is 0 comma 5 and minus 2.5 comma 0 for this coordinate. For this coordinate, for this graph, we are having 0 comma 0 and 1 comma minus 2. Which is x less than 1. Now for this one, look at this one, look at there is a relationship, or what's the difference among these three? Look at this one. The thing is that this one has 2 variables, which is x and y. This one has 2 variables, which also x and y, but this one has only 1 variable, which is x. Therefore, we don't need any coordinate, we need only 1 point. We can say that, okay, this equation is a straight line when our x is equal to 1. Now, let's now continue. The next thing now is we want to represent this on a graph now. So let's assume that this is our graph. Don't forget, Wahida work or NECO, you'll be provided a graph sheet by Wahida work or NECO or any of the SXZ examination body. Now, don't forget to indicate your y as 6 and your x as 6. This is 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4. Now, the scale that we use, this from here to here represents 1 centimeter. And the implication of this is that on x-axis, we use 2 centimeter to represent 1 unit. Because from here to here is 1 centimeter. And from here to here is 1. That means that from here to here is 2 centimeter, which represents 1 unit. Let's now move to our y-axis as well. We also use the same scale that we use for our x-axis, that is 2 centimeter, to represent 1 unit. On that note, we can even conclude by saying that on both axes, 2 centimeter, we use 2 centimeter to represent 1 unit. Now, let's now go back to our inequality graph. Now, the first thing is we have what concerns us here is our coordinates. We have coordinates when our x is equal to 0, y is equal to 5. When our x is equal to 0, we go to where our x is equal to 0, which is origin, then y is equal to 5. We move to where y is equal to 5. This is where y is equal to 5. Then the second point, because we have a straight line, we can't use this one for a straight line. So to have a straight line, we need this other point, which is this. When our head is equal to minus 2.5, then our y is equal to 0. When our x is equal to minus 2.5, this is where our head is equal to minus 2.5, then our y is equal to 0. We have this. Now, we now want to join the two lines together. Now, this is where we now need the application of our inequality. That is first stage. Now, the stage is if we are given greater than, because for this we have two lines. It's either we use a thick line or we use a dotted line. It depends on the inequality that sign that we are given. If you are given greater than or you are given less than, so you use this dotted line. But if you are given greater than or equal to or less than or equal to, you use a thick line. So that's the difference between the two. Now, let's now go back to this. We now want to join the line together. I mean the point 5 and minus 2.5. Now, are we going to have a thick line or a dotted line? Depend on the inequality sign that we are given. So we are given less than. That means that we need a dotted line, not a thick line. So use your ruler to join them. So this is a straight line. Now, before we proceed to the second one, on that line, please take note this, because these are the things, this one of the things that normally make students to lose a mark. Please don't trivialize any mark. One mark as a mathematician, one mark is very important to you, because difference between success and failure is 1. 49 and 50, they are not the same. 49 is this 7. And 50 is last credit. Because of what? Because of 1 mark. Now, look at this. What will be written on this line? You go back to this. Because you use this one to draw your line, you write this, not this. On no account must you written this on your straight line. So you write it. You write this, which is y minus 2s is equal to 5. Y minus 2s is equal to 5. Now, where our solution side will be. Now, in order to know where our solution side will be, is it this side or this side? Now, let's get back to this now. We have y minus 2x less than 5. Now, here, you can use either x or y to determine where your solution side will be. Now, let's use x. You can now use, if x is equal to 0. So if our x is equal to 0, we will have y minus 2 into bracket 0 less than 5. Therefore, we have y minus 0 less than 5. So y less than 5. Now, we now go to where our y is equal to 5. This is where our y is equal to 5. And the solution is less than 5. So we have this, all these ones greater. If you take any number here, it should be greater than 5. And if you take any number here, it's less than 5. And according to the question that we are given, is y less than 5. That is your solution side. Just indicate it with arrow, because it's not the only line to be drawn. We still have other two. Now, the question now is, what if I decide to use x? Yes, you can use x, and we are still going to get the same thing. Let's assume that I want to use x. That is, if, go back to this, if y is equal to 0. So we have 0 minus 2x less than 5. That's it, minus 2x less than 5. Divide both sides by what? Divide both sides by minus 2. Thank you. Minus 2x less than 5. Therefore, this, divide both sides by what? Divide both sides by coefficients of x, which is minus 2. So we have minus 2x divided by minus 2 less than 5 divided by minus 2. Now, during our introduction, we say that we have two conditions that can make the coefficient to change. The first one, we say that is turning point, whereby the second one is negative effect. So this one now, in as much that we divided both sides by negative, we can say that x less than because of this negative, so this one will be affected. It will now be greater than minus 2.5. That means that we go to where your x is equal to minus 2.5. This is where your x is equal to minus 2.5. Greater than, is it this side, right? Your right side or left side? Greater than is your right side, which is this. So we are still going to have the same thing. It's either you use this or you use other one. We are still going to get the same thing. Now let's now back to the second one, which is this one. So for the first coordinates of this one is 0, 0. When x is equal to 0, y is equal to 0, which is this. That is origin. And the second one is when x is equal to 1, when x is equal to 1, y is equal to minus 2. When x is equal to 1, y is equal to minus 2. So this is it. Now, we are going to join the line together. There is going to be a thick line or dotted line. So because we have greater than or equal to, then we use a thick line. So use your ruler. Now, on your graph as well, you write y is equal to minus 2x on your graph. Not y greater than. I've told you, because if you write y is greater than, or you write any inequality sign here, it will be minus 1. So that is why you just have to be very careful. Now, where to be shaded? Where is going to be our solution side? Let's go back to this place. Now, substitute that if our x is equal to 0, so we have y greater than or equal to minus 2 into bracket 0. That's y greater than or equal to 0. So that means that we go to where our y is equal to 0, which is origin. This is where our y is equal to 0. So greater than 0, is it up or down? So greater than 0 is simply mean up. So which is this side? Just indicate it. And the last but not the least is when our x is equal to 1. We go to where our x is equal to 1. This is where our x is equal to 1. Now, we now want to have a straight line here. Is it going to be a thick line or dotted line? Because of this less than, and because of this symbol, which is ordinary less than, so we have a dotted line. So that is x is equal to 1, not x less than 1. You write x is equal to 1. Now, where to be shaded now? So just go back to this with less than 1, less than 1. So this one, we don't need to use any value for x or y. You just said less than 1 is left-hand side. So our solution side is here. Now, me looking at this graph, a region or a boundary region that satisfies all the three conditions is this side. So this is what you call required place. So this is your final answer.
That's the much we can take today on the program. Join us next time for another educating session.